Thank you. And now I'm going to invite Ron Ross to say a few words.
Well, thank you very much. This is a great honor for me to be here today and be involved in this tribute to my dear friend, Marshall Abrams. Marshall has been my friend and colleague for over 30 years. I first met him when I was the division chief at NSA. The division was C81, and we were the division that published the Rainbow series, developed and published the Rainbow series. And I remember my very first day on the job, I got a phone call from the guard desk, and they said, there's some guy down here with a Russian Cossack, red Cossack with the gold star on it. And he said he wants to come see you. So obviously that was not a good thing for the first day of my job at NSA. So I went down to the guard desk, and who do I run into? My first day of my 30-year friendship of Marshall Abrams. He was a classic jokester. He's always just involved in the leading cutting edge projects. And as people have said today, he's one of the smartest people I've ever met, but he had that wicked sense of humor that really caught my eye and really bounded us and our friendship over the last 30 years. Marshall was involved in supporting the work that I was involved in for almost that entire time until he retired. The first thing that was mentioned earlier is he actually had input to the Orange Book, the Trusted Computer System Evaluation Criteria. That was the first real standard for operating system security. And he was very much involved in that project, as well as the Trusted Network Interpretation, which was known as the Red Book, as someone said earlier. These were the foundational documents that set the stage for computer security for the next 30 years. And a lot of those things have been forgotten about, but we're starting to bring some of those concepts back today. He was also involved in the federal criteria, which was our transition from the DoD-related security criteria, trying to move that criteria into more of a general commercial space so it could be applied to all systems, not just the DoD and the defense systems. And of course, later, when I went to the National Institute of Standards and Technology, Marshall was very much involved in all of our FISMA-related publications, from the Security Controls Document 853 to the Risk Management Framework. Every step of the way, providing his valued judgment and his lifelong experience in computer security, and helping us make those documents better every day that we work together. He also worked on industrial control systems. We had the tough challenge of applying the NIST controls to industrial control systems. In some sense, they were very different than the general purpose systems. And I remember taking many trips with Marshall to some power plants around the country and talking to individual engineers and seeing how those security controls could be applied to those industrial control system environments of operation. Again, a very critical aspect of the work that we did together. And then there was my other two pillars of my relationship with Marshall, and they've been mentioned today as well. ACSAC, I've been involved in ACSAC for many years, and Marshall, his leadership and his vision for that conference and making it unique among many, many conferences today. I'll never forget all of those contributions that he made. We also, the New Orleans conference is my single best memory of the ACSAC. I think it was in 1996. And of course, some of the best food and camaraderie and just great computer security dialogue that conference brought in. And it was largely due to Marshall's leadership and, of course, all the other people that supported him and that vision over the years. And finally, the love of model railroads. I had no idea that Marshall was into model railroads, which is one of my passions as well, until we started talking one day and ended up understanding that he had not just was a fan, he had a whole basement full of model railroads. It was an unbelievable model railroad set that he had put together. He had a whole bunch of people come over and run railroad operations. And I just, I'm going to miss him greatly, because not just on a professional level, but a personal level, one of the best people I've ever met in my life, kind, gentle, smart, and he brought the best. He made this world better, and while he was here, and we're going to miss him greatly. And thank you again for allowing me to share my thoughts with you this morning.
Thank you so much, Ron. And thank you all for sharing your nice thoughts and for remembering Marshall with all his kindness and greatness in our field. And I will invite Jeremy to continue our session. Thank you all.
Thank you, Gabriella. appreciate those thoughts. I miss Marshall as well. Turning to another piece of history, but one with some more interactive involvement, it's my pleasure to share with you a little bit about the the Test of Time awards that we have here at ACSAC. This is the second year we're offering, we're awarding these, and I'll tell you a little bit about them and tell you who our awardees are, and then we're going to have a discussion about those papers that received awards. So the definition, and this was written by Kevin Butler when we started thinking about Test of Time about a year and a half ago, is that it should be at least 15 years old, and it should be a paper that meets the test of time, should be one that's had significant impact, maybe through impact in academia, maybe through impact in industry, maybe it caused creation of a product or a new line of thought or whatever. Frequently, but not always well cited. In the early days, citations were less common, and so we didn't want this to be a popularity contest based on citation count. We wanted to look at what really impacted things. And so last year, we awarded Test of Time awards to 7 papers and their authors. And we were able to have 6 of them join us in person at the event in San Juan. For those of you who remember when we used to get on airplanes and travel to places. The 7th one was Ross Anderson, who was unable to travel for visa reasons. And so hopefully he will be joining us this morning. I don't see him in the system yet, but hopefully he'll be joining us. For this year, we selected 3 papers as representing the test of time. And I'm just putting the titles here so that when you hear the references over the next hour or so, that will be, you'll know what the papers are we're talking about. The names in blue here are the names of the authors who are joining us today. So we have 2 authors of the first paper, Calvin Coe and Carl Levitt, Marianne Zerko representing the second paper, and Lee Badger representing the third paper. We had a great selection committee for this year, and as I wrote this down, I realized that it might look like the people who were receiving the awards were on the selection committee. That's not correct. People who received awards last year were invited to be part of the selection committee this year. The people who received the awards last year were selected by a group that did not include any of the recipients. So this was our selection committee, and I thank them very much, and we'll be doing it again next year. And so with that, I'm going to stop sharing, and I'm going to invite Carl, Mez, Lee, and Calvin to unmute and uncloak themselves. And I'll give you a brief introduction for each of them, which is really hard because all of them have done amazing things in their careers. And then I'll ask each of them to talk for a few minutes about the importance of their research, how they got there, and what impact it's had over the intervening years. So in no particular order, Calvin Coe has over 30 years of experience in computer and network security, with particular focus on isolation, intrusion and malware detection, and vulnerabilities. He pioneered the specification-based approach to intrusion detection, which is what this paper is about, and which has been adopted in various commercial products. He was the chief scientist of CyberInc, leading the research and development of a malware isolation browser. Before that, he was a computer scientist at Sparta, McAfee, and Trusted Information Systems. Carl Levitt recently transitioned to emeritus status after 32 years at the UC Davis Computer Science faculty, where his greatest joy was working with many talented students such as Calvin Coe. From 2005 to 2009, he was an NSF program director for what eventually became the SATC program, which I now lead. So I think that's a kind of a cool link that Carl and I have. He spent 20 years at SRI International's Computer Science Laboratory, and he tries to stay engaged in security research, graduate student supervision, and participate in NSF panels. And here's a fact that I was unaware of about Carl. He grew up in the Bronx, which I had sort of guessed from his accent, and he was a student at the Bronx High School of Science. That didn't surprise me, but he was captain of the basketball team. I didn't know that about Carl. That's pretty cool. He may be the only security guru we have who captained a basketball team. Next, we have Marianne Zerko, who is a technical staff member at MIT and Lincoln Labs, Mez, as she's known to her friends, and probably to people who aren't her friends also, has worked in product development, early product prototyping, has over 20 patents. One thing she didn't say in her bio that she sent me is she has her very own Supreme Court case. She's one of the few people in our field who has her very own Supreme Court case. She defined the field of user-centered security in a publication at the New Security Paradigms Workshop in 1996. She's a founding member of the National Academy's Forum on Cyber Resilience, where I get to work with her still, and serves as a distinguished expert for NSA's Best Scientific Cybersecurity Research Competition. Lee Badger's interests are primarily in access control for security, particularly as it can be added to operating system kernels. He's contributed to software implementations of domain and type enforcement, generic software wrappers, and self-protecting mobile agents. He's led technical teams at Trusted Information Systems, as did Calvin Coe, and at the National Institute of Standards and Technology. He served as a program manager at DARPA, where he tried to recruit me, and he funded programs in intrusion tolerance, self-regenerative systems, and software that automatically collaborates for collective defense. I should also mention that Lee and I worked together building one of the first secure Unix systems, commercial secure Unix systems in the late 1980s, where we got to dig into the guts and find all sorts of vulnerabilities in Unix source code back before that was popular. So that, I'm hoping Ross will join us. For those of you who don't know Ross, I'll just tell you a little bit about him, and if he joins, you'll have to tell him that he's already been introduced. He's a professor of security engineering at the Department of Computer Science and Technology at the University of Cambridge, one of the founders of the field of information security economics, author of the textbook Security Engineering, which you can get copy, I think the last version you can get for free online. I think the most current version you have to pay for, I'm not sure. He's a founder and editor of Computer and Communication Security Reviews, which is how I met him. When he started that, I was one of his reviewers, and he was elected about 10 years ago as a fellow of the Royal Society and the Royal Academy of Engineering. So quite an incredible group of folks who have done amazing things. I have not thought about which order to invite you to speak, so I'm going to randomly select Calvin to go first.
Thank you, Jeremy. So Carl, like to see you all. So yeah, I haven't seen you guys in a long time. So the paper I was written when I was still a student at UC Davis with Carl. So the paper provide an approach to detect attack that exploit vulnerability in privilege program. And we did it by monitoring the execution at runtime using, at that time, using audit trail. And the monitoring is with respect to the security specification, basically saying like what file it should access, what network behavior it should have. And this is based on, at that time, have an observation that many attacks involve like exploiting vulnerability at that time, so-called privilege programs that usually run with super user or administrator privilege to perform the attack action. And usually they're exploited because they're vulnerability, like buffer overflow, and so that the attacker can gain additional privilege. However, we find out many of them, their intended behavior is pretty restricted, like the file they access, the network they're going to do. So the idea is to try to specify their intended behavior and detect any action beyond that. And we, at that time, we we prototyped that with Sun Microsystem, BSM, Audit Trail, and then later we also did some of that with the new Linux system. So later we call this, people call this specification-based detection because it involves crafting of valid behavior, specification of system program and system component. And at that time, most intrusion detection approach focus on like detecting statistically anomaly or crafting attack signatures, which are the step the attacker perform. So this approach at that time is kind of new and has the potential of detecting new attacks. And on the other hand, it also requires some understanding on the system semantics, the programs and the system and underlying policy. So I believe the idea has been adopted in some commercial system, and then the idea has been applied to other system component and like network protocols such as ARP, DHCP, and there are also other further work in reasoning about all this specification program to understand the overall security posture of the system. Yeah, that's my summary.
Thank you, Calvin. And Carl, since you worked with Calvin on that, would you like to add anything else to that summary?
Not much, except you know, I would say that we can oversell it. We're saying, well, we wanted to detect previously unseen attacks, and this is great. We actually can do this with 0 false positives and 0 false negatives. I won't say if we achieve that at all, but anyway, it's a good goal, and because. But anyway, I'll let that go for now. Let the others talk.
Okay, great. Thank you, Carl. Mez, you created this new field, usable security. I mean, you were one of the mothers of it, along with Lori Craner and a few of the folks. Tell us about how you got into it and how it happened.
In terms of how I got into and created usable security, I was working on a high assurance A1 virtual machine monitor. And I was seeing that the systems analyses we did, as well as the deployment configurations, didn't include what administrators did and how they configured it. Back in those days, things that were highly secure were shipped with a configuration that everyone knew was not usable. No one used the secure configuration. That was the configuration it was evaluated under. This made me very sad, and I thought that, in fact, it was the natural extension of security models to include what human users did back then, largely administrators. So, if you don't mind me transitioning into the paper that and so I published at the New Security Paradigms Workshop in '96 the notion that user-centered security could actually be a thing. Literally, people at Oak and Lind laughed at me in the hallways, literally. So not that I hold it against any of you. I mean, none of you are probably here right now that laughed at me then. So, so the Test of Time paper from 2002 was the first usable security paper with an attacker. Back then, I had no IRB. I was in. It's
an IRB for people who don't know.
Yeah, Institutional Review Board that checks the ethics of your human studies. Usable security studies today absolutely need them checked, whether or not they work in an institution with an IRB or an ERB. Today, now that I'm at MIT Lincoln Laboratory, for my sins of having no IRB for many years, I have 2. I have one through MIT and I have one through the federal government. So I get to put my human studies through 2 of them. It's yay. We were, however, in this Test of Time paper, sensitive to potential human harm, and we made sure to count the number of flames that we got. It was less than 1% of the responses. So back then, that seemed pretty good. So besides being the first usable security paper with an attacker, it's also the first usable security paper to measure users in an ecologically valid context, AKA in the wild. So while SAS and Adams were doing self-report studies within organizations, and Witten was measuring users, it was in the lab. So ours was the first to put together measuring what users actually did in a security circumstance in context. And the third claim to fame this paper has, and I only thought of this one at the time, I didn't think of the other two, was that it was the first usable security paper on active content, aka code permissions. This was, again, 2002. The first mail service was 96, JavaScript in 95, cross-site scripting in 2000, CSRF in 2001, and yet nobody was measuring what users do when they get alerts or any sorts of attacks or anything like that. There are 8 references in this paper, which is a ridiculously small amount. And 2 of them were my previous work. One my Oakland paper and one the New Security Paradigms Workshop paper. For context, what we were doing in the Nodes Domino organization, in a product organization, was changing the active content security permissions, execution control lists, from shipping open to shipping closed. And in particular, unsigned code, which actually should never happen, but did. And this mirrored a number of themes from Emily Stark's keynote, if you were around for yesterday's keynote. One of our themes was sometimes you have to respond to new attacks and find new vulnerabilities. And we found when we internally changed the defaults from open to close and ran all our tests that we actually had some additional vulnerabilities that needed to be fixed. We were tightening the ECLs and that increased the warnings. So we already had warnings, but basically pretty much nobody ever saw them because everything was shipped open. Management believed that the warnings would be sufficient in case of maliciousness. So engineering did not. We didn't think it would work. So what we did is construct an in the wild study that was as favorable to management's position as possible. So in a 500-person organization that worked with Lotus Notes Domino, we sent code carrying email with timing events to see if employees executed unsigned active content and if their defaults had been secured. And we skewed it 3 months ahead of time. An internal security maven sent everybody email talking about secure ECLs, putting in a button what people could just press on using that active content to secure their ECLs, showing an example of an unsigned alert, saying this was a bad thing. So it was all the priming and prompting that you're not supposed to do in usable security studies today. But we wanted to have zero argument if we were right. We measured who had their defaults open and who allowed email with content to execute, even if their defaults were closed through timing events. And we weren't able to measure people whose defaults were closed and didn't let things through. So our email asked those people to respond to us so that we put them in the gold star club. Because basically we used malicious, some not malicious, but active content, potentially malicious active content to do the measurements. We found 40% of the responses were people that just clicked through. And by the way, our default was a bore. Our default wasn't actually okay. So we even had the dialogue defaults right anyway. But as we know today, people still click through. 31% of the people respondents still had an insecure configuration, and only 28% were what we called gold star. By today's standards in the usable security literature, the measurements are pretty primitive, right? Just like percentages of responses. But it was enough to get what we needed. It was actually, frankly, better than engineering feared, but much worse than management feared. And again, this organization was totally a technology savvy organization. These were your smartest users you were ever going to get. So we actually did get a number of features including the ability to lock down the permissions for users through administrative content. And so it was a success story in terms of what we wanted out of the product.
Great, thank you, Ms. And Lee, I'll give you a chance to talk about domain and type enforcement in firewalls.
Okay, so I view this work as a phase and an ongoing development of more and more convenient but mandatory controlled execution environments. Environments that we can lay on to practical systems and try to gain some extra confidence and security about the unruly, unknown software that we always want to use. Before I get into any more of the details, though, I'd like to pause and just note that I'm representing the paper, but this was quite a team effort because we built a big prototype and there's a lot into it. And the team was Karen Ostendorp, Chris Vance, Wayne Morrison, Michael Petcash, David Sherman, and Dan Stern. And so I'm representing all of our work. At this time, this was the late 1990s, we were not the only people to notice that firewall protected security perimeters were crunchy on the outside, but soft and squishy on the inside. And also that they didn't protect against outbound attacks. So if you lost control of your software on the inside, lots of evil could occur. And finally, we were concerned about the need to collaborate with other organizations with some sort of trustworthy common cyber territory, and firewall perimeters were just in or out. There was no us, when two firewall organizations tried to interact. And so we were thinking about that. And then DARPA let out a broad area announcement promising funding for people to think about this. And then we thought about it very, very hard. And then we put together this proposal because we realized, hey, we've got several building blocks. We've got this, this access control technology called domain and type enforcement, which is mandatory. I'll get to that in a second. And we also had the TIS Firewall Toolkit. And so if we put these together, maybe we could add some defense in depth and some strength to firewall security parameters. So domain and type enforcement is a derivative of Boebert and Kane's seminal work on type enforcement. Type enforcement is a table-driven access control that's centralized. And so every time a subject, a running process, tries to access something like a file, there will be a table lookup and the requested access would be checked. If it's not in that cell of the table, the answer is no. There was another table that would mediate subject-to-subject accesses. And so we thought that was just wonderful and it could do lots of things, but it was a little hard to use and it didn't map naturally to the natural structures within operating systems. For instance, operating systems like Unix you can think of them as being comprised of two trees. There's this vast tree of files, and then there's and it's fairly stable usually. And then there's a smaller tree of processes. They're unfolding and contracting. It's very dynamic. There are fewer of them, but they're out there. And so what we needed was an access control technique that would restrict and govern those interactions and would be somehow comprehensible to a human. And rummaging through hundreds of thousands or millions of files, stamping labels on them is not very easy for a human to do. And so we came up with the notion of doing it implicitly. We would say, well, and we made a language for it. So in our specification language, you could say, hey, all the files beneath some place in the hierarchy are of a single label, a single type. And then the access control mechanism could dig that out of a runtime database as the system would run. This turned out to be really helpful and a confirmation of the idea that laziness is a good idea when you're inventing new mechanisms in an operating system. So we got that going and it was convenient and fairly agile. The other part was the TIS Firewall Toolkit, and that was written by Marcus Ranum. And that gave us, it's an application gateway firewall, and it gave us some very nice, straightforward implementations of things like Telnet and FTP and RLogin and so forth. Many of the things we don't use too much anymore. So we said, we have an opportunity, to apply our access control technology to this firewall toolkit and build a much more robust and defended security perimeter. Around that same time in other work, we elaborated our domain and type enforcement to encompass the network. And it's important in the network that we be able to control packets, that we have types on the data that packets are carrying. But we sure would like not to obsolete all the traditional protocols by adding data to them where they don't expect it. And we were fortunate to discover that IP planned for this a long time ago, and there's something called an IP option space. And we were able to actually encode all of the security attributes we needed in the IP option space. And so we were able to achieve interoperability with networks, traffic, and protocols that didn't know anything about our enhanced security. And this sort of goes along with our DTE approach of getting some interoperability by not littering our system with a bunch of labels that everything should check but doesn't know to check. So that actually was a success, and it allowed us to consider how to get endpoints to coordinate about how they treat data. So like if I'm sharing my document with you, I'd like the label on your end to be the same. I'd like you to run it in a similar execution environment and protect it similarly. And so that was our basic strategy. In the golden case, we had this vision that there would be multiple DTE systems communicating across multiple firewall perimeters throughout the internet, and there would be all this domain and label information being exchanged, and protection would be consistent, coherent, and there would be defense in depth. Now, that didn't happen. However, we showed that, yeah, I'm seeing you laughing. We showed that it can be done, and it's actually not that hard to lift. It doesn't impact performance that much, and that the hard part is the human, getting the specifications and policies done. And we think that creating the specification language helped a great deal, but there's always this cost and benefit trade-off, and writing the specifications is a picky and difficult process to get straight. However, we also discovered that just like we were able to say, oh, all the files in this hierarchy have the same label unless we say differently, we could apply that same strategy to networks. And so we could take a look at the address space of class ABC networks and the host IPs that are in them. And we can say, oh, wow, all the hosts in this part of the network space, we will impute to them the following domain. And we will assume that all the traffic from them has the following type, unless we see otherwise. And so we were able to basically paint, the hosts out there that didn't know anything about our work with DTE attributes, so that then when our system read the packets in from that, they could access, control, and operate with it as though it had been sent from DTE systems. And what this allowed us to do is say, well, they may not know that they're working with us, but we've decided that certain hosts can be trusted to a certain degree, and we will connect up those particular hosts to particular well-suited domains that we have formulated in our system. And then it will be coherent and defense in depth. Not as good as if DTE had conquered the internet, but a good solid step beyond not having any defense in depth. So we did that. There are basically two different scenarios. You could have the server on the inside of a DTE protected enclave, and you could run your important service that you'd like not to get beat up in there. And then you can imply attributes to outsiders, to outside clients, and that works quite well. Or you can do it the other way. You can have your clients in your DTE enclave, and as they reach out, you can control them. You can make sure that they don't go to the wrong places. More importantly, I think, is you can make sure that if they're going to bad places, or even any places out on the internet, they're not also going to sensitive places on the inside of your enclave. And so that gave us some leverage on the outbound attack problem. So the work, as I say, I think it was a phase and an ongoing process of building better and easier to administer restrictive execution environments. And I would argue that I'm delighted, that this paper's significance has stood the test of time. I didn't know until Jeremy reached out to me. But it makes sense that such ideas are still relevant because, software and organizations are exchanging software a lot more, and it's so much connected. So it seems like the problem is still not solved.
Great, thank you very much, all of you. So now we're going to go into some discussions and questions. There's 3 sources of questions. The most important one is from our attendees. Please put your comments in the Pathable application. I have a window open there. I'm watching for your questions and comments. The second most important is for the 4 of you to talk to each other. And the third is the questions I have for you. So even though it's the least important, I'm going to start with my question, which is what interactions do you see among the 3 different papers you represent? For example, do you see that the needs for usability drove or should have driven some of the work that Lee did and that Calvin did and Carl? And similarly, did the 3 of you who were building the systems, do you think about how to make it more usable? And I'll let any of you talk about that.
Well, I want to say something about them. I like about Mez's usable security work is that it's trying to inspire us. Can we build a usable intrusion detection system? So as we all know, the ones that are based on anomaly detection, which sort of a lot of sort of predated machine learning, of course, but that doesn't matter. Anomaly detection systems don't explain themselves. They say, something's wrong. Something doesn't violates what you've done before. It doesn't. So I think building a usable intrusion detection system is a good vision, and I'm inspired by what Mez has done in that regard.
So I'll just jump in and say, just from my own little point of view, digging through kernel guts and trying to make those abstractions somehow coherent to outside administrators, usability is an enormous challenge. And so when Mez was talking about her work in usability, I was thinking, yes, and sure wish we knew more about it back when we were doing our work back in 1997.
And I think, interestingly enough, even with the blossoming of the usable security area since 96 and since 2002, getting at the challenges of expert demographics, like administrators, like developers, it remains a big question mark. Their tasks and their tools are more complicated. Ecological validity is much more difficult to get in the lab. Therefore, controlled experiments are harder, and there's not a lot of organizations that are going to let you in to actually look at your administrators and how they're doing their security administration work, or how the intrusion detection is being deployed, and so on. So the kinds of areas that we represent and that frankly I've always been most interested in are remain a huge challenge to develop research that helps us get it right.
So at NSF, we funded projects that have put anthropologists into security operations centers, which is kind of a cool thing. People, when we first saw the proposal, it was like, huh? And the more we thought about it, it was like, this is a really cool way of understanding how different people look at problems and coming up with different solutions. And I think we're seeing a lot more of the interaction between usability and traditional security, if you will. So Calvin, I had a question for you, thinking about your presentation, the expression, all that's old is new again. And in particular, using some of these techniques that you pioneered, I'm seeing a lot of people talking about this sort of thing in IoT spaces, Internet of Things devices. How much do you think they've learned from what you did? Are they aware of that you did this, or are they reinventing it all from scratch?
Well, you know what, I actually did not follow that, so I really don't know what they doing right now. So
Okay. Okay.
yeah.
Fair enough.
Are you thinking of MUD? Are you thinking of MUD, Jeremy, or something else?
I don't have a particular
Okay.
thing in mind. I see a lot of proposals of people trying to say, well, we're going to specify that IoT devices, because they're not as unpredictable as general purpose computers, they run a relatively fixed set of software. They're not like, I mean, if you look at a continuum, there's the computer on your desk, which may run pretty much anything if it's not a controlled system like in a corporation. And through some level, and your phone runs software that's had some level of vetting, but there's millions of different apps that it could be running. All the way at the other extreme are IoT devices, which are only running the software, hopefully, that the manufacturer provided. And so maybe along that continuum, maybe some of these approaches are more feasible on the IoT devices and could use both Calvin's work and Lee's work to constrain them in ways that we couldn't constrain, or that are very hard to constrain for a general purpose computer.
Yeah, and Dave Bellinson points out that there's a lot of work like that in ICS, for example,
Right.
which is kind of like, it's embedded systems, so it's not.
Yeah,
anyway.
yeah. I should say more broadly than just IoT, ICS and CPS and all those other three-letter acronyms. Yeah.
Building on Mez and just to build on what Mez and Jeremy just said, I think in IoT world, we're basically dealing with devices that interact with the physical world, and we can perhaps more easily write specifications for what the behavior of these physical devices should be, because dealing with the physical world, with physics. If something goes wrong, it's violating the laws of physics. So it should be easy to write the specs. But
well, there is some of that because, for example, I've seen discussions, I don't know if this is implemented, that if you have an intrusion detection system, sort of anomaly detector on a car, if the wheels say they're turning at 60 miles an hour and the transmission says it's in neutral, either you're going down a steep hill or off a cliff, or one of the sensors is malfunctioning, or maybe you're on ice and so the wheels are spinning or something, but it's not normal to have these physical things disagreeing with each other. So maybe there's ways to write specifications like that. Jim Elvis Fox asks, as a follow-up to my question, what's the best way to inform the next generation of developers and cybersecurity professionals about the older foundational work so we can build on the lessons learned? And any thoughts on that?
Oh, you bet. Tweet about it. Absolutely. And I'm 110% serious, right? Every single one of us should now get on Twitter and do a tweet on ours, and then somebody tweet on the previous ones. If it's not on the web, it doesn't exist. So, and a lot of people get their cybersecurity updates on Twitter these days. Frankly, my Twitter feed was entirely tuned to keeping up with all things cybersecurity until about a year ago, and I didn't change who I followed. But then it became all things pandemic with a dose of politics. So I'm hoping it just naturally goes back in 2021 to all things cybersecurity.
Jim was one of my favorite UC Davis students, of course. Okay, he's been at Idaho for many years and built up a security program there. But I think Peter Neumann, I think, has tried to publish get some of the old papers online. I guess he scanned them, and a lot of them are just old reports that never made into papers, but they're fairly good material. So I don't know, Jeremy, perhaps we can make these available through ACSAC, I guess, or some way. They may already be also, but.
Some of them are, yeah. Matt Bishop, your colleague, also has a database of some of the classic papers. And in ACSAC, we've had, for a number of years, we ran a series called Classic Papers, where we asked people to update their papers. And so we had people like Matt Blaze talk about what had changed and so on. So we've had a number of things like that. Let me ask one more question along those lines, tying to Jim's question. oh, and Daniel Fagan points out that there's the information bookshelf on the ACSAC website. And so that's another great place we can put things. That was something that Marshall Abrams founded. So it would be an honor to him to add some of these papers. Copyrights are something of an issue, but we can do it. So the follow-up I wanted to ask is, I recently saw a number of proposals that were talking about tagged architectures, and no references to anything earlier than, say, 2005. It doesn't mean that that it's impossible that there's new research in tagged architectures that's legitimate. Things change. The fact that we have faster processors makes all sorts of things, and multiprocessors makes all sorts of things that weren't feasible 40 years ago or 50 years ago feasible now. How do we get people to, as Mez says, recognize things that aren't on the internet, that not all history is on the internet?
Well, a question for Lee in that regard. Okay, so several people said, I won't give his or her name, said that fine-grained access control is impossible to manage. Okay, and I think DTE sort of solves that problem in many ways. Am I overselling it, Lee? Okay, I just want to put you on the spot. Okay,
it's absolutely miraculous. No, I'm kidding. I think that's a heartwarming endorsement, but we ran into policy complexity pretty quickly when we tried to approach what we considered to be a minimality of privilege across the system, because there was a profusion of domain definitions and types, and that led to kind of a complexity that was difficult for the administrator and even us who built it to grok. However, that said, we also discovered that if you only have one issue in your mind and you create a very small policy, you can create a small policy in something like DTE, not to sell DTE, but a small policy that fits on a screen, really small, like maybe 40 lines of specification, that would provide many useful constraints. For example, we developed such a policy that would run the entire system in one big blob domain, right? But would run particular users or applications just in these tiny little domains. And that policy could be very small. And if that's all you're interested in, is you're not worried about minimizing, hardening the whole system, but just bottling up, a few programs or a few user activities, you can do that with a policy that actually is comprehensible, or comprehensible, I should say. Mm-hmm. And we thought for a while about the opportunity. There might be an opportunity of saying, instead of having the one great policy that will do everything for everyone, maybe instead we should have a whole lot of little policies, and they should all be stacked up. And when the system is running, and so as the system runs, it checks each little policy. But then each person who writes a policy or reads a policy only has to read or write, their understanding of the one particular concern. And so we did do, some thinking about that, but that has its own complexities too, because after you get a certain number of checks stacked up, when something fails, when something says no, then the running program has a really strange error message. It's hard to figure out what happened then.
So Charlie Payne asked a question that you just answered. And so I won't ask his question, but I'll ask a follow-on to it, which is, that's one way of looking at the problem is, say we're going to isolate this part, and this is the part we're going to try to harden, and we're going to just ignore the other part because the other part was, say, blocked by a firewall, and so we don't need to worry about it. Another approach that there's been discussion about is, imagine you've got a Linux, you're using Linux, and so you want to build Linux in such a way that it just doesn't have certain parts of the system in it, and therefore you don't have to worry about securing them. And so, I mean, it may be as simple as you don't have certain daemons installed, but also you don't have certain parts of the kernel installed. Maybe you don't have a file system. You can rip the file system out, or rip the ability to write into the file system. Maybe you can only read it from the file system. And that, using that model as a different way to strip things down and say, this is easier to say things about because there's less of it. I wonder what the trade-offs are in your mind for doing a stripped down approach as opposed to a constraining approach.
Wow, that's a wonderful question. And I'm lucky to have been thinking about that in the past. Something to say. So people have thought about it. There was a project called Linux from Scratch, where you could take your average kernel hacker and say, here are the building blocks, and put it together. They're also, I mean, that's hard though. That's really hard, but you can make your own. Little less ambitiously, there are a number of minimalized Linux distributions. I had the opportunity to work with something called, I think it's called Solid Core, Core Linux, Tiny Core, that's what it's called, Tiny Core Linux. And you could configure it, like you say, without many things. And this kind of Linux, we were interested in running it in virtual machines. And so it was very important to us that it be small and lightweight and quick to start. And boy, was it. It was, I think the distribution was, if I'm remembering right, I'll get the number wrong, tiny. It would launch in seconds, you know, from disk. And you could have lots of them lying around. But one of the problems we had with it is that there was a lack of support for, you know, things like weird issues like, oh, your disk partition is too big. You know, the file system code, the low-level code, just since it is so simple and doesn't have all the different cases accounted for, it's not counting for the newest hardware or for very large sizes of things or for things like virtual memory. I think there was a version of this that was all in memory. There was, you know, it would run without ever touching a secondary storage device. And so it had many advantages, but it was also, you had to be careful because you could end up spending a good amount of time, you know, trying to figure out why something didn't work. And you would be able to make it work in the end, but it's a question of time.
Mm-hmm. So Daniel Fagan asks, we talk about usability, we talk about assurance, especially in things like DTE. How do we gain assurance in usability? What mechanisms exist to gain the same confidence in our processes that we have in our technology?
So measuring them and their results in the wild is the best we got as far as I know. I'm not aware of any sort of, you know, provable specification languages of user actions in a secure system, particularly when under attack. But, you know, for example, and unfortunately, we don't have a lot of user models around user activity in the large grain. I mean, the Chi community has like models for things like typing and movement, right? But those kinds of models, I don't know of any that have extended. So that's hard, right? I attempted once to ask about whether or not the usability of Ron, of I don't think I was asking Ron at the time, of a subset, it might have been Lee, I don't know, anyway, but anyway, of a subset of the NIST security standards were actually usable. And what I got told was that it got lots of review comments. Well, you know, right? And I dearly wish, for example, that NIST standards that talk about organizational behaviors would actually even just run some qualitative studies about how those standards are used and how they work. Quantitative, even better. I know that we've got usable security folks inside NIST. I know that the most recent NIST authentication standards have absolutely used research results in both passwords and 2FA to inform their standards, and that's super exciting. But there's a lot more that could be done, even at this less guaranteed level.
So Calvin, Lee, Carl, and Mez, if any of you have questions for each other, please feel free to jump in. Otherwise, I'm going to throw another one at you.
I just wanted to mention, you talked about subsystems, we talked about classifiers, and we talked about subsystem system. I remember there's a classifier by Nickel, it might have been 40, 50 years ago, and something how to do that. What are sort of rules you can take for taking a large system and subsetting it? And this isn't inspired by maybe some of the difficulties with 360, which is meant to cover everything from, I don't know, many microcomputers to large mainframes. And then something else brought up the point of policies too. So you want to subset the policy too, because different subsystems will offer different policies. And I think it's a good area to do research on yet still. But I don't know if anybody remembers that paper by Nico Haberman. Okay, I think, anyway, it's a thought.
Anyone, any thoughts on that?
So yeah, I'll chime in a little bit, though I don't remember that paper, Carl.
No, you're too young.
It's not available on the internet, so it must not exist.
So we, using our specification language, we tried to enhance it because we thought maybe we could have modules, just like programming languages. You don't try to write everything in your main program, all the statements together. You make functions and classes and modules and split it apart and abstract things. And so we tried to do that with DTE, and we ran into this problem. It may be in that we didn't take the right approach, but we ran into the problem that the modules that we formulated were controlling the same underlying mechanisms in the system, the same processes, the same files and packets and all that, the same things all at once. And so unlike a case where you have two modules or multiple modules in an implementation of a program where they can be somewhat independent, they can share data structures, but they may not share every single data structure. Whereas with our DTE modules, it was kind of like each module was in fact sharing every single data structure with every other module. And so it was harder to modularize that kind of attribution of security attributes and rule-based decision-making where the decision was split up, in a modular way like that, in a single policy. I think that'd be a little different than the notion of, well, maybe we should have multiple policies and they're all independent. We just do them all. That's maybe, that's where I ended up thinking that it might just be easier, but that has its own problems of understanding what an access denial means.
So one of the downsides of this being a virtual event is if this were a real event, I would turn to the audience and point to people who have not spoken up and ask them, the teacher in me or the professor wannabe in me.
There's a whole tab. There's a whole tab you can scroll through and see all the names.
Yeah. So I encourage people other than the usual suspects to be chiming in with your thoughts on this discussion. What I was wondering about is a little bit about how we would, well, okay, let me back up. So for most ordinary users, the two most likely places where they run across usable security issues are SSL, which Emily talked about yesterday some, so won't rehash that, and phishing experiments to figure out who clicks on the link and then you slap their hand or do whatever you do. What did you think about back? I mean, you touched on this a little bit, Mez. How have things evolved and what should we be doing in terms of the ethics of experimenting on our user communities, not just the technical side, but the ethical, and IRBs are concerned with harm, but they're not necessarily concerned with ethics. So can you share some thoughts about that?
So I am not an IRB expert. As I mentioned, actually even having an IRB is only 3 years old to me. Well, I've been doing this so much longer. Let me also say that in conference paper reviews, reviewers in the usability community and by extension the usable security community are actually looking at the ethics beyond my IRB approved it. And there's a great deal of robust discussion about whether it is or is not the place of a reviewer to say, well, your IRB may have approved it, but it's actually not ethical. Just to give one very concrete example, there's an emerging norm in the MTurk community about how much MTurkers should be paid, gig workers online should be paid.
Can you define MTurk? Not everyone knows that probably.
Yeah, Mechanical Turk is a basically online tasking gig worker platform. There's a couple others, prolific, I forget what else, where you can basically say, take this survey and I'll pay you $2, for example, or even to do a thing, imagine you're banking, construct a password. For instance, if you want to, attempt to handle passwords, but not handle real passwords. So tasks and surveys, oversimplifying. And the pay for that used to be pretty poor. And now the norm, though not quite entirely established, for getting your work published is that you paid minimum wage for the context you got, and you can restrict what countries you get from, though the U.S. minimum wage usually is enough for many countries, and you basically just measure how long it will take to do your work, and then pay at least that. But that, no IRB, I don't think any, actually I've been told there's an IRB that checks for that now, but for a while no IRB checked for that, but it became more and more emerging norm. Even if there weren't ethical considerations, it's really potentially dangerous to handle some of this stuff. I never want to handle people's passwords, ever, because of reuse and the potential for leakage. But it's very hard to see what will really happen with any mechanism that includes humans if you don't believe in an attack, if you don't have something that approximates an attack.
And sometimes it's surprising. So some of the early Unix versions, for example, when you've had a failed login, they did not log the username of who failed to log in, because due to slow response times in those early days, it wasn't uncommon for people to type their password when that's for their username. And you didn't want the password to get logged in a log file. So the way you avoided it is you didn't record the username, which of course, when you were trying to figure out who was being attacked, it didn't work. So this, in a sense, it was a usability trade-off because of usability.
Yeah, and it turns out, we were thinking very simply back then, and because we had fewer cycles. But now you can log it if the name is valid, right? And so you can actually find out who's being attacked. Now you can't. That doesn't help you with attacks that are guessing potentially valid names, but you can at least get closer.
Yeah. Terry Benzel asks, I'm concerned about the lack of formal-based approaches to measure usability. I think there are new approaches to modeling human behavior, agent-based, that is encouraging. And this is actually something we talked about in the graphical user interface research that I did back in the late 80s and early 90s, is we were trying to prove our system correct, and we could prove the software, but we didn't know how to even think about proving the user interface.
And I would love it if Terry would like put in a citation or two. What she's talking about, that's emerging is better, because, you know, frankly, with so much to keep up with, I do not keep up with the Chi community per se. I keep up with usable security and aspects of cybersecurity, like web security. You know, I don't know how many of you are on a, you know, top tier cybersecurity program committee, but there's just so much. You got to basically just stick to one area these days.
That's true.
So yeah, if there's stuff happening in Chi, I'd love to hear about it.
Yeah, that goes back to actually what I was saying in the introduction about Ross Anderson. He started that Computer and Communication Security Reviews back in about 1990. That's how I met him. And the goal of that magazine was to provide 1-paragraph abstracts of every publication in the security research area. And we managed to do it for a number of years until it got to the point where there was so much that you needed a huge team to just do it. But it was a great way in those early days that you could know everything that was going on in research at a high level simply by reading that journal every month.
and that is another way you could teach those young whippersnappers what foundational stuff was out there, is be on a program committee and insist they cite it.
That's true.
They hate it when you do that.
Okay, so Terry is offering the work of Jim Blythe on human agents, and in particular, the DASH system in Deter, and she will find other citations, not just from Chi, but other communities. Just for the benefit of people who are listening who may not know some of the communities in usable security, SUPS is the big conference, Symposium on Usable Privacy and Security. Chi, what does Chi stand for? Computer Human Interaction or something like that?
Yes, exactly.
Is the other big conference that is not specific to security, but has a lot of security in it. Scott Roddy also says the ACM Conference on Human-Computer Interaction. Yep. Okay, Scott also asks, it's come up repeatedly that we wish we knew more about usability when some of this early research was done. Nevertheless, even in modern research, it seems like application security, cryptography, etc., and usability security are two different research communities that just happen to present at the same conference, but have limited collaboration. What do the panelists think is the right way forward to marry these together throughout the entire research life cycle, and not just to use usable security as a measurement at the end of the process? So I'm going to actually target this one at Lee first. Had there been usable security folks out there, how would you have used them and integrated them into your research project instead of putting them at the end?
Wow, that's a great question. So strangely, and in a very simplistic way, we considered ourselves to be focused a bit on usability because the prior mechanisms had been tables. And we said, oh, let's make our approach more in line with how the system really works. But more importantly, let's make a little language. And the language allowed you to use, you know, like in C or whatever. It allowed you to use descriptive names, and it allowed you to format it with spaces and tabs and put comments in, things like that. So that it was, I think, a step in the right direction. So we were trying to be more usable and more friendly to the administrator. It was totally selfish because we were just struggling, you know, to configure systems that didn't have that kind of help. Had we had, you know, so, but the honest answer is that we would definitely have consulted with usability experts at our earliest, as soon as we had any real concept of what we were making. I mean, you can't ask a question until you know what you're making. But sometimes by the time you know what you're making, you've already said a whole bunch of what it is, how its structures work. And that kind of might, some of those decisions might make it more or less possible to make it a usable system. So probably we would have asked for assistance maybe after about 6 months, where we were no longer completely embarrassed about what we were talking about or thinking about, because we at least penned it down a bit. And then we'd have tried to make some course corrections. I mean, with the benefit of hindsight now, seeing how incredibly important it is that people can get some confidence they know how to use their software, and they know how to configure it, and what denial and access denial means, and how to set a policy statement. Knowing the foundational importance of that now, I'd say we would keep the doors wide open and probably just pull in usability people from day one, and try not to let them leave. I don't know, put bars on the doors.
The question also dealt with sort of marrying subdisciplines of security, and a slightly different topic. When I worked for the government, we always got asked about metrics of security. Of course, the DARPA gets asked that question too on occasion. But and several people I work with, I'll leave names unsaid, said, "Can we change the topic?" Okay. And but the cryptography was mentioned, and I think the metrics, I think we can sort of, cryptography sort of deal with work factors of, you know, breaking crypto systems, whether it's, you know, guessing the key or breaking the algorithm itself. And I think, yeah, we can, I think we learn from that to try to come up with metrics for some of these security mechanisms that we build. It's sort of obvious point, but I think crypto inspired metrics for security mechanisms, I think makes sense, and something to work on. It's sort of obvious, but I think it's worth saying, though. Yeah.
So going back to Scott's question about getting the different research communities to talk to each other, as Mez was saying, excuse me, we've become such a huge community. Each of us goes in our own corner to discuss our own topics. How do we get them to talk together? Well, one of the goals of ACSAC is, in fact, because we apply, we like papers that bring together applications of technology, and so it's a good place to get those communities to talk to each other. I mean, it's certainly not the answer to all the problems. Some fields have one conference a year for the entire field, and then there's subtracks for each area, but that forces people to be in the same place and interact with their peers, while those of us in computer science broadly and cybersecurity more narrowly, we each have our own little corners. To us, a conference like ACSAC of 200 people is sort of a mid-sized conference, while for some fields, anything less than 10,000 is small. So maybe part of the problem is that we've segregated ourselves into 100 different conferences instead of having one or two conferences that everybody shows up at. Just a thought. How I don't know how to solve that problem, though. We have about 10 minutes left, so if there's a couple last questions, and then I want to give everyone a chance to share some final reflections on how their research might affect things in the future. Sort of a contemporaneous reaction. Lee, I want to go back actually both to you and to Calvin. Are the products, firewalls in your case, Lee, and Calvin, you know, was a more general system, are there still remnants of those things in products today? And would the products that we see today, would they be improved if they used more of your technology?
Well, from what I see, there are products that sort of have the similar idea. They well, I actually work in industry in the last couple of years, so people, like from what I know, is the product team doesn't have a lot of time to look at research. They need to solve a problem, and but there are definitely some using similar idea, like they look at what attacker does, and also they basically trying to write rules about like what the system should behave. So I can't say like, but usually that's not a very systematic and also very product specific and also customer specifics. I guess some of the work and research about reasoning, like as Lee said, you have many modules and many like small policy, and when they compose together, what does it look like? And I think that types of research may be beneficial to that respect. Yeah.
So I only have kind of a soft answer to that question. I've had the experience of running into someone from a major company that I'll not identify, not for negative reasons, just keeping it anonymous, who was very aware, who was in the operating system group and was very aware of DTE, which that surprised me that the company was aware, and at least some of their operating system developers had thought about it and were interested in it. So that's not to say that it transitioned, that it is currently embedded in anything. It's very, very soft. Similar soft possible lingering effects are that firewalls these days are sometimes distributed as appliances, network appliances, and they can be separate hardware. They can be in containers, operating system containers. And an operating system container, or a lightweight virtual machine, is a really interesting example of a restrictive execution environment, because it can be configured in lockdown. Some of them can be configured in lockdown to provide many of the benefits that we were trying to get early on with our access control work, but with some additional benefits, which is that from the vantage point of a container, one might have a much simpler view of the system. So if your system is trying to do multiple things at once, you don't necessarily have to have all of those goals intermingled, in your policy. And with containers, there's a way to kind of work on that, I think. So I'm encouraged by that. I cannot claim that that work was influenced by our work. I do not know, but I think it's similar in spirit. And so I just point to that.
Okay. Well, we all know that every invention stands on the shoulders of some other inventions. That's just the way it works in science. So I'm going to, unless anyone has one last question they want to share, let's go to a wrap up. And Carl, if you'd like to share any thoughts of things we should have talked about or anything else.
Okay, so there's a lot of work on intrusion detection. I guess it started with Jim Anderson, and Dorothy Denning wrote a classical paper on it, and maybe in the 80s, and other people did some pioneering work in it. But you would, and instead of trying to promote resilience, which is sort of, in my mind, sort of deals, okay, we detected an attack, we think it's an attack, what do we do about it? Okay, how to respond, and how to respond in a way that preserves the system mission, how to make the system survivable. We can always think of words that sort of to try to determine how to respond to it. So I think that this is a hard problem, and I haven't seen much done on it. And I think it's something that I think we should think about. And I think, and there are all sorts of ways we can respond, and we can build on and work on control systems. A lot of work's been done on that, but it makes assumptions that probably aren't realistic as far as linear systems. Anyway, just a thought. I know you've been pushing for years at NSF, Jeremy, and I don't know how much has really been done effectively on this. Not your fault, of course.
Speaking of which, Carl, did you have the same phone number I have now, 8338?
Yes. Oh my goodness.
Okay. Carl Landwehr also had that phone number. Carl Landwehr also had that phone number. Wow. It's a storied phone number. Okay. Mez, would you like to go next? I never had your phone number.
Sure. In terms of thinking about the full featured security community as it was when it was smaller, and the way that our various early work interacts, I would put up a pitch for the systems sub area in cybersecurity research. These are people who do systems work today. And let me just tell you, they have it really tough publishing in a world where you're pushed to get a lot of papers out fast. and narrow provable or measurable results are much more easily evaluated than what contribution a full system brings. But I think that is the one place where a lot of the older experience of thinking about cybersecurity of the full system, including the usability, might still reside. And we might look at that as a place for all of our work to go forward.
Great. Calvin?
I don't have anything to add.
Okay. Lee?
I think I'm in the nothing to add category at this point.
Okay. Well, before I let you go, I want to show you, let's see if I can make this work. I don't know if you can see this. So I haven't had your plaques made yet, but it's going to look something like this. I don't know if you can see and if the audience can see. I'm going to mute you, Lee, because it wants to show you. Marcy, can you make my screen come on? No. Okay, I'm not sure why this isn't working, but you can sort of see it. It's kind of hard to show because it's clear. And this is one of the plaques actually for the scholarship winners, but yours will look somewhat similar to this. So I'll look forward to mailing them out in the old-fashioned mail because I haven't figured out how to email you a plaque that works very effectively. So I ask the audience to join me in thanking the four of you for a great discussion. I hope everyone reads the papers. We'll have links to the papers on the ACSAC website. They're not there yet, I don't think, but we do have a place on the ACSAC website for all the test of time papers. I encourage everyone to read. These are things that have, in my mind, had a lot of influence over many years. So thank you all very much.
Thank you.
Thank you.
And we'll be back in, let's see, in 15 minutes. There will be 3 breakouts, tracks A, B, and C, and hope to see you in those breakouts. Thanks, everyone.
Thanks, Jeremy.
Thank you, Jeremy.
Bye, Carl.